Hello you guys, and welcome back again to LinoCalc SI. Today we're going to do our last video for this semester on just a topic. I'm going to do one more final review after this, but this is our last section on integrals. So we just talked about definite integrals, and so I wanted to go a little bit more into what a definite integral really is. So I'll write it out. Integral. And the way it looks is if I was doing, so I drew out fx here. So if I wanted to do an integral from a to b of f of x dx. That's how you write it out. You have the integral symbol and a dx at the end. And that means I'm going to be taking the integral of this function between the points a and b. So on here, the way it would look, if this is a and this is b, then we're finding the area, because remember the integral of a function is the area under the curve between the points a and b. So we're finding all of this space. And that's what our solution would give us. That's what this is equal to. Another fun thought experiment, not thought experiment. I mutter, that's what I do. So if we have a function, pretend this was f of x for a minute, right? It looks a little bit like sine. And I needed to find the area between a and b. The basic way that you do an integral, this would be positive and this would be negative. So you can have different questions. I don't think Calc 1 goes very far into it, but different questions asking for this positive area and this negative area to just solve for the overall area in between. Or you'd solve for the overall area and pretend this was positive, and then you'd have to solve for two separate integrals separating it at that point. That's more of a calculative process, but it's neat to think about positive area above the x-axis, negative area below the x-axis. And going into here, when I solve this integral, once I find, I'll make f prime, big F prime equals f of x, right? That'll be kind of our notation. So once I solve for the antiderivative here, what I do is, normally this line notation was what I was taught. So now we're evaluating from a to b this f of x. Yeah? So that means I plug in I plug in b first. F of b minus f of a. So it's like we're plugging in this amount, and in this picture it'd be like solving for the entire area from x is 0 to x is b, and then we subtract out the part to a. So that way you find the area between a and b. Sensible, right? So let's see it in action, the algebra bit of it. So here we're finding the definite integral from 0 to pi over 4 of cosine of 2x dx. So here I'm just going to do the derivative first. And also I apologize if this notation is a little bit off. I can't remember if the line goes on this side or the other side of the function, but it's not a big deal because it's just, I use this just to remind myself that I'm evaluating at these points. Calc 2, it'll come up some more, and just find a way to make the numbers make sense to you. That's what it's there for. And so antiderivative cosine, we got sine, and don't need to worry about the negative because derivative of sine is cosine. And 2x stays the same inside, but chain rule, if I had taken this derivative, I would have had to multiply by 2. So I'm going to divide by 2. I don't need a dx anymore because we solved for it. And now I plug in pi over 4. So sine of now pi over 4 times 2, pi over 2, divided by 2, minus, plugging in our 0, sine of 2 times 0, still 0, divided by 2. There we go. And what does that equal? We have sine pi over 2, unit circle. That should be 1 over 2 minus 0 over 2. Sine equates to the y part, right? So we should get 1/2. And that's it. That's a very basic example, of course, but that's a definite integral. And yeah, this ended up being a very short video. So I should be posting this weekend the test review information. So please, please, please comment anything you want me to focus in on. Otherwise, I'll just be doing another general video like Dr. Solio did. Yeah, other than that, best of luck, and you guys will hear from me this weekend. Hopefully I hear from you guys before then. Take care.